open up GoodNotes here and take a look at, all right, here we go. In order to, let's see, in order to find the surface area and volume of a sphere, you need to know the two equations that kind of work with these two things, okay? What is the equation for surface area? What's the equation for surface area? Come on now, look in your book. This is part of being able to find and figure things out. Chloe?
4 pi r squared.
4 pi r squared. Okay, so this is pre-algebra, 8-8. And we are dealing with spheres today. I love spheres. All right, and the surface area formula is 4 pi r squared. Where have we seen that pi r squared thing before? Yeah. Area of a circle, okay? So, we know that the area of a circle, circles have radiuses. Okay, circles have radii, yes, all right, is pi r squared. But when your circle becomes a sphere, and we'll draw a dotted line to make it look like a sphere, then you just multiply that area by 4, and it works, believe it or not. Now, the radius of a sphere, is it really that much different than a circle? You always measure from what to what? Emma?
From the center to the edge.
From the center of the sphere to the edge of the sphere. Now, what's interesting about this is instead of now being just spokes on a wheel, okay, now I could measure out to here as well. And that would also be the radius. Okay, so not only are your radiuses going up and down and side to side, but now they're going in and out because it's a three-dimensional object. Grace.
Wouldn't it have to go all the way to the edge? I mean, you only get like half.
I took it all the way to the edge. That dotted line is the edge of the sphere.
Oh.
That dotted line in the front is the front, and that dotted line in the back is the back of the sphere. It just looks smaller because of the way we're looking at the sphere. But actually, in all reality, it's the same. Okay? Yeah, Emma?
Couldn't a radius be like go straight up?
A radius could also go straight up. Ooh. Okay, there's a radius. A radius could also go back there as well. Okay, so all of those are radiuses. They all start at the center and they go out to the edges of the sphere. And that's the only value you need to find both the volume and surface area of a sphere. That's actually somewhat easier than all the others because you don't need to know height, you don't need to know perimeter, you don't need to know circumference. You just need to know radius. That's it. Now, how do you think the book will try to trick you up here? What will they probably give you instead of radius? Reagan.
Diameter.
They'll probably give you diameter of a sphere, right? They'll probably give you a sphere, like so. Dotted lines to show that it's a sphere, and they'll probably give you a line that is across the middle like this, and they might give you a center point. What do you have to do if they give you a diameter? Yeah. Divide by 2. Yep, and then you'll have your radius. All right, now before we work any problems with surface area, let's switch over real quick to volume. If you turn the page, you'll see that, page 394, they give you a volume equation. Anybody want to offer up that equation, please? Grace?
Volume equals 4/3 times pi r cubed.
Excellent. 4/3 pi r cubed. What's different about this? Yep.
The 4/3 and the radius cubed.
Very good. First of all, the 4/3. What did we do? We divided by 3. Okay? It's very similar to what we did with cones and pyramids. Okay? Very similar indeed. But now we also took the radius and we didn't multiply it by itself once. We multiplied by itself twice, which means r times r times r. That's 3 r's. So that's r cubed. Okay, and that's the volume of a sphere. Okay, so I have a sphere. Okay, that's the volume. That's everything inside the sphere. Kind of looks like a brain, sort of. Okay, so there it is. Everything inside the sphere. Why might this be useful? Anybody? Where would you want to calculate the volume of a sphere? What kind of applications in real life would this be necessary? Yeah.
Maybe making a bowl of some kind.
Okay, a ball of some kind. Sure.
A bowl.
A bowl?
Yeah.
Do you eat out of spherical bowls?
No.
Yeah, a little tiny hole inside you.
Maybe you could
You
use
squeeze
half of a spear.
She puts her pudding in a volleyball and squeezes. Okay? But she needs to know how much pudding to put in the volleyball. Of course. Before she squeezes. Just make sure you squeeze in the right direction so you don't shoot the alien in the eye. Okay? What else? Where else do we do this? Water balloons, right? Water balloons are somewhat spherical. You might fill a water balloon. You need to know how much water it can hold.
But that's
Much
just,
water
you
as
just
you
fill it up and
can,
then
so
if it
it
explodes,
hurts
you know,
and
it
it
can't hold that
gets
much.
Oh, that's trial and error. That's terrible. You might waste them. You don't want to waste them.
My mom buys like the 5,000 pack because she would go through
Oh,
and that's what my
okay.
mom does too. She buys like the 1,000 pack or whatever.
Mm.
So many water balloons.
If you're a geologist or an astronomer,
What if we're not going to be?
where might it be beneficial to know how to find the volume of a sphere? Yeah.
Like if you're gonna, I don't know, go to try to fit the moon in your spaceship.
Okay, the moon in a spaceship. That would definitely be necessary.
I'll bring it
Big
back
spaceship.
Like
Bring it
Gru
back
on
home.
Despicable Me, he
Okay.
shrunk the moon and tried to fit it in.
Emma, you realize that's not
Wow.
real life, right?
Okay.
You might look
Astronomers and other scientists have to be able to actually measure how much stuff is in the Earth, how much stuff is in our sun, okay, etc. So we actually use equations very similar to volume to figure out the volume of these objects just based on their size.
How do they know what the radius of the sun is?
Because they go in there.
Well,
with tape measure.
You can't get the
You can't.
radius of the
You
sun.
can't. For instance, let's say I take. Okay, this is Bob. Bob is a very happy stress ball. Okay, so when Parker's in my classroom, he's doing all that. Okay, but nonetheless, I don't know the center because I can't get to the center. Okay, but if I look at Bob like this,
Does it really
I can see edge to edge. What can I measure?
Mm.
Diameter. I can. From the very outer edge to the very outer edge is the diameter, so long as it goes through the middle. So I can find the widest point of Bob, that's the diameter. What can I do to find the radius? Divide by 2. How can we see, or how can we measure stars and planets then? What do we use to measure the outer edge of planets and stars? What do we use?
A tape measure.
Not exactly. Not exactly. Tape measures.
20 miles.
I have one of these upstairs in my house. I like to, in the springtime, look at the rings around Saturn with this. Okay? What, Chloe? Telescope. We use telescopes. You can look through a telescope, and Galileo did this. He looked through a telescope, and he was able to see Jupiter. He could measure Jupiter. And he was able to measure Jupiter, and he was able to predict Jupiter's size. And he realized very early on, Grace Pennicamp, that it was massive. Absolutely massive. So, you can find the volume of a sphere just by measuring its widest point and dividing by 2. Alright, we can do this, and it's important to do this. Another place this becomes important is if we are going to drop a bunch of spheres into a liquid. Okay?
You need to know how much water it will displace.
You need to know how much water it will displace, right? The volume of a sphere is going to take the amount of water that would normally take up that space and remove it. Okay? So let's say, for instance, I need to wash all of my bowling balls. Okay? And I fill the tub, thank you, half full with water. Well, I need to know that if I drop 7 bowling balls in my tub, that my tub's not going to overflow. Okay? That's important. I don't have 7 bowling balls. I have 0 bowling balls. But if I had 7 and I were to drop them in my tub, I'd want to make sure my tub, besides maybe falling through the floor, can hold it without spilling water.
I was gonna
Okay.
say, wouldn't it like break like I'm probably.
Probably not. I weigh a lot. I probably weigh way more than 7 bowling balls.
But dropping it.
Well, I wouldn't drop them.
You just said if I dropped.
Okay, I know I used
Colby
poor
takes
language.
things literally.
He obviously. Okay.
If,
Alright, how many of you feel like you could do this?
I
You could apply. So what would you do? You'd find the what? Radius, and you plug them into your formulas and you solve. Now, let's say that I'm going to use the volume formula. Okay? Do I take and do 4/3 times pi times r times r times r?
No.
What does order of operations tell us we should do? We should always do our exponents first. So I should always multiply r by itself 3 times, or cube it. Okay? Then multiply by 4/3 pi. Alright? And if you haven't gotten in the habit of using your pi key yet, start trying to figure it out. You can always double check by multiplying by what number? What's the number for pi if you had to use that without using a pi key? 3.14. So try using the pi key and seeing if that works. Sometimes using the pi key is a little bit difficult on some of your calculators because you've got to hit 2 buttons to use it.
Then you have to hit second.
You have to hit second and then the pi key. Right.
Do I have Caleb.
I don't know.
Caleb just went.
Kind of got to figure it out. I will work through a couple of examples. If you would like to start on your homework, you may.
What's homework?
I already showed it to you.
What is it?
I told you to write it down.
What you said, write it down if you won.
Oh, well, then I guess you didn't want to. So you can watch.
Oh.
I would need a magnifying glass.
All right. Here we go.
Wait, I think he's
You have a sphere. That's more of an oval.
Use your autocorrect thing.
What do you mean?
Oh, wow.
I got it. Thank you.
Wait, is this the first one?
It is 4 months. It is the month of the sun. I don't know.
Okay. I'm going to tell you that this distance is 10 meters. Okay, just so you know, this would be a very large planetarium of sorts if it was actually that large. 10 meters is roughly 30-some feet. It's close to that. Okay, 10 meters. I want you to help me find surface area and volume. All right, surface area, 4 pi r squared. Okay, what's the radius of this particular sphere going to be? Drake, what's the radius going to be?
5.
Yes, it's going to be 5. So I plug in that number. This is very important. You get in the habit of doing this. 4 pi. Then you put in a 5. You square it. Now, I like to put it in parentheses like that because it tells me that's what I have to do first. Most of you should be able to do this except pi, should be able to do this in your head. 5 squared is what? 25. And Connor, do you know what 4 times 25 is? Come on, do it in your head. 25 plus 25 plus 25. It's 100.
What is 1 squared?
So this is going to equal 100 times pi. Which means when you multiply it, all you're doing is you're taking pi and you're moving its decimal 2 places. So without even using a calculator, what should your answer be? 314. And since I gave you meters, it's going to be surface area, so it's going to be meters what?
Squared.
Meters squared. Okay? You should try to do this stuff in your head. Okay? You don't always have a calculator. This one was pretty easy. 25 times 4 is 100 times pi, move the decimal 2 places, 314. All right? Now, on to volume. Volume. Volume is a little different. It's 4/3 pi r cubed. All right? Now let's plug in what we know. We have 4/3, we have pi, we have 5 cubed. Anyone know what 5 cubed is without using a calculator? Yeah.
125.
125. 5 times 5 is 25. 25 times 5 is 125. And if you count them up, it makes sense. 25 plus 25 is?
50.
Ladies and gentlemen, that's pretty slow to be in pre-algebra class now.
50.
Plus 25
75.
plus 25
100.
plus 25.
125.
Not terribly difficult.
130.
No, Colby.
Okay. That's 5 cubed.
We can see.
What'd you do that for?
It's gone.
Yeah, it's something.
I got 131, so I.
Colby, stop. You know that. No way.
See if it brings up a code again.
Colby, no.
All right. Okay, here we go again. So, let's pick up where we left off, which is right here. 4/3 pi times 125. This is where you're going to probably want to get your calculator out. It's probably somewhere around 150, but I don't know that for sure. Okay? Maybe more like 150-ish.
Do it in your head. I thought you can do everything in your head.
Well, pi is 3.14 times 4/3. The 3's in the bottom are going to be roughly equivalent and cancel. So it's going to be 4 times 125, roughly, maybe a little bit more. So it's going to be 400, 500, probably right around 515.
I didn't say you had.
523.
You're bad.
Shoot.
Drake, I doubt you could have
I was off by like 8. Oh, well.
I
Okay.
don't even know how you can do 125 times the 4/3.
Well, yeah, you could.
No, I couldn't.
Watch what I did in my head. 4/3, 3.14. This is estimation strategies, just so you know. Okay. What can you tell me about these two things right here? They're very what? Hang on. They're very close, right? So if I was to estimate this, I would say that they would probably almost cancel. Almost. Okay? There'd be a little bit left in the top. So that means that I'm really multiplying a majority of what this is going to be, 4 times 125. So what do? I take 4 times 100, and I take 4 times 25. Because I'm just multiplying the pieces. This is 400. This is 100. That gives me 500. And because of the 0.14, I add a little bit. So I say 515 for good measure. And you say it's 523. Okay? So what I'm doing is I'm estimating. And what my hope is that when I'm done, my answer on my calculator is very close to my estimate. That way I know I've done my math correctly. So 523 roughly is our answer. What's my units?
Units.
Meters cubed.
Meters cubed. Excelente.
Excellent.
I know.
Okay. So we found surface area. We found volume of the sphere. That's what they're going to ask you to do in your assignments for this evening. Your assignment.
You already said it.
I did, but let me stop the recording.